Hello everyone. In this video I will discuss the proof of E is an irrational number. An irrational number. So here we all know that E is equal to 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus dot 1 upon n factorial plus so on. So it is an infinite series, and En is equal to, suppose En is equal to the sum of first n plus 1 terms. That means 1 plus 1 upon 1 factorial plus 1 upon 2 factorial up to 1 upon n factorial, right? So what will be the E minus En? E minus En will be 1 upon n plus 1 factorial, 1 upon n plus 2 factorial plus dot so on up to infinity. So all the terms in this series is positive, so sum will be positive. So this is always greater than, strictly greater than 0, right? Now here we can write E minus En is equal to 1 upon n plus 1 factorial plus 1 upon n plus 2 factorial plus 1 upon n plus 3 factorial plus dot so on 1 upon n plus capital N factorial, right? Where n tends to infinity. So this summation is actually infinite series, right? So here we can take this n plus 1 factorial outside. So what we will get? We will get 1 upon n plus 1 factorial limit capital N tends to 0 infinity. Here we will get 1 plus 1 upon 2 n plus 2 plus dot so on plus 1 upon n plus 2 n plus 3 up to n plus n. Okay, now here we can write, in place of this we can write n plus 1 factorial limit capital N tends to infinity, and see this, what is less than or equal to 1 plus, since n plus 1 is always less than, strictly less than n plus 2, so this will be less than n plus 1 upon n plus 1, and next term will be less than 1 upon n plus 1 square, and last term we can compare it with n plus 1 to the power capital N. Okay, now see this is geometric series, geometric progression, GP. So what will be the sum of this, nth sum of this series, this n terms? This will be 1 minus, here r is equal to 1 upon n plus 1. So using this formula, Sn, that means sum of n terms, is equal to 1 minus r to the power n, 1 minus r multiplied with a, first term. So here first term a is equal to 1, so we can write this sum is equal to 1 minus 1 upon n plus 1 to whole power capital N divided by 1 minus 1 upon n plus 1. Now this when n tends to infinity, this denominator tends to infinity. So this fraction will, this fraction tends to 0. Okay, now from here we will get n plus 1 divided by n, and from here we can write 1 upon n into n factorial. Okay, so this expression is actually 1 upon n into n factorial, right? Now see here, E minus En is always greater than 0, right? From here, and this is less than in fact strictly less than 1 upon n into n factorial. So this is the very important inequality. Actual proof is starts from here, but this inequality is very important in this proof. So now suppose, on contrary, suppose E is an irrational number, so we can write E is equal to P divided by Q, where P and Q are integer, where Q not equal to 0. So what we can write then, see here, in place of n we can write Q, right? So because this is true for all n, right? So we can write E minus EQ, in place of n we can write Q, and 1 upon Q into Q factorial. Now from here we can derive this expression, 0 is less than Q factorial multiply this whole expression by q factorial. So we will get q factorial e minus eq and will be less than 1 upon q, right? Now see, here we have q factorial e minus eq. So we can write it as q factorial into e minus q factorial eq, right? Now see here, this q factorial into e. What is e? E is p by q. This is our hypothesis, right? So we can write in place of e is equal to p upon q. So this will be an integer. Why? Because we have a q factorial, and q factorial is just a multiplication of first q integer, positive integer, right? So this will be an integer, in fact positive integer, and this will again be an integer. Why? Because of this, because of the nature of this definition. Okay, so this again will be integer. So integer minus integer will be integer, again integer. Okay, now see, this is an integer, and we all know that q is integer, right? Q is an integer, so this will be always either less than or equal to 1. Okay, in case it is a positive, otherwise we will get contradiction. So what we are getting between 1 and 0, we are getting an integer, which is a contradiction. We are getting an integer in between 0 and 1, which is an absurd. That's why our hypothesis that this is an irrational number is a false, and we proved that is an irrational number. Okay.